Well, hello, everyone, and thank you for joining us today. We'll start off with a few admin items. We have disabled video because we have quite a few folks on the call today, and we wanted to reduce any potential strain on WebEx. We've also muted everyone on entry to help prevent background noise. If you have questions during the session, please post your questions in our chat box, and we'll be happy to answer your questions on the spot if we can, or during the question and answer section at the end of the session. In the past, we've had quite a few questions regarding time charging for webinars like these. So I do want to let you know that this session is considered voluntary and there is no charge code from us. However, as always, talk with your TOL supervisor if you have any questions. Earlier today, we emailed out a PDF with the slide deck that will be referenced during the session today. But if you did not receive the PDF via email, we've posted a link in our chat box where you can access and download it now. We are recording today's session and we will post the recording in our Degreed page as soon as possible. If you need the link for our Degreed page, please let us know in chat. There is also a link in the slide deck as well. And one last quick reminder, if you're having trouble with audio or video, we recommend disconnecting from the Cisco AnyConnect VPN. Slide, please, John. So our agenda today, we'll start with some quick introductions and then go right into the main part of our presentation, which is Red Hat and Kubernetes 101. We'll follow that up with some training opportunities and finish with Q&A. Next slide, please, John. So again, thank you all for joining us. My name is Jamie Hill. I am one of the program managers in learning and development. I'm based down in Augusta, Georgia. I've been with the firm for 8 years and with learning and development for about a year. With me today is my colleague, Scott Cormack, and I will turn it over to him to introduce himself. Scott?
Hello, everyone. Again, my name is Scott. I've been with the firm for about 2.5 years and learning and development in particular for about 4 months. I am based out of Virginia, and I would like to introduce Geraldine, one of our presenters from Red Hat.
Hi, everyone. My name is Geraldine Yamas. I'm the Federal Training Manager over at Red Hat, supporting Booz Allen Hamilton's training. I'm also based out of Northern Virginia. I've been with Red Hat since last December, and I'm excited to talk training after John tells us all about Kubernetes.
Thanks, Geraldine. I'm John Walter. I am the Solutions Architect for the training team in North America. I'm based out of Raleigh, North Carolina, at the headquarters of Red Hat. I've been at Red Hat about 5 years now, working a bunch of different roles, and excited to talk to you all today about Kubernetes and OpenShift and some of the training opportunities that we have. So I guess we can get started. So just a quick agenda. We're going to talk a little bit about containers, kind of the smallest compute, right? Move out to Kubernetes and then to OpenShift. Towards the end, we'll have time to talk about some training. And we do have, as Jamie mentioned, time for Q&A at the end. Obviously, if you have questions throughout, please feel free to drop them into the chat box. And if we can answer them right in the moment, we will. Otherwise, we'll have plenty of time for Q&A towards the end. So let's jump right into it. First off, what is a container, right? Obviously, and it's funny, every time I talk to people about Kubernetes, I always have to use the term digital transformation, which I think is just the cheesiest term, but it is kind of becoming the industry norm, right? And when we talk about digital transformation, we're really talking about how you become a great software company, right? And that requires a lot, right? It's not just implementing something like OpenShift, right? It's about changing from waterfall development towards CI/CD, or deploying into deploying in data centers to deploying into the cloud. There's a lot of different components, and the goals of these steps should really be to focus on the business outcomes. We're trying to increase speed, we're trying to increase agility and control, and what we mean is speed, meaning new ideas can be deployed more quickly. Agility, meaning updates, changes, they can be done more simply and allow for greater experimentation. And then for control, it's mitigating risks, right? Making sure we're minimizing issues with bugs, and that those kind of issues can be approached more quickly. And really defining a new method for integration, right? We need our apps and even the way we approach the design of them to be a lot more agile. They need to be scalable. They need to exist across private, public, hybrid clouds. And ultimately, you have to be able to iterate quickly and efficiently on these. So Obviously we have kind of our enterprise service bus model here on the left. We're more moving towards these modern architectures. We're moving towards microservices, and even the way that our teams are designed are changing as well. And so the question, what are containers? It really has a lot of different answers depending on who you're talking to. So, if you ask someone on your infrastructure team what a container is, they'll get into a lot of what I'll talk about in the next few slides, kind of what the infrastructure impact is with containers, right? Being able to have multiple versions of an application running on a shared kernel. They're a lot less upkeep than virtual machines would be. And they can run on pretty much every environment. Whereas when you talk to application developers, they're talking about, oh man, I can package all my applications with the dependencies they need to run. I can deploy them with a click of a button, via self-service. I can submit my application to a CI/CD pipeline to create a container image that can then be used anywhere, right? And so traditionally, obviously, organizations have really co-located their applications across, virtual machines. And this is really due to the operational overhead and the resource costs of maintaining VMs. And while VMs are isolated from each other, the co-located applications, they have zero isolation, and they can negatively impact each other, whether it's the files, the configurations, the behavior of the applications. Whereas Linux containers, they share a container host and they share a kernel. And at the same time, they're using the kernel technologies, things like C groups, things like SE Linux. And then all of this is to provide isolation so that one container can't access or impact the other containers that are running on that same host, or impact the host itself, unless obviously you design them that way. And so containers are becoming, in a way, a virtualization technology. Virtual machines are for virtualizing the hardware, while containers are more for virtualizing the application processes, no matter where they're running, whether it's bare metal, whether they're virtualized, whether they're running in the cloud. And while it's possible to run every application on a single VM, the operational overhead, the resource costs, all of this, all these extra VMs that would be required to do that, it really kind of invalidates any of the benefits, right? And VMs, they have advantages, right? There are still going to be workloads that need to be running on virtual machines. They have an advantage with, providing hypervisor level isolation for the applications, but that comes at the cost of running, a full-blown OS for each application, and that's going to consume memory and CPU. And VM's compute and memory capacity, it's all predefined. You can't really easily provide any elasticity or bursting more when an application requires more memory or more computing power. And so containers provide that isolation through really taking advantage of some of the kernel technologies. So things like I mentioned before, control groups, namespaces, Linux, all of these have been battle tested. They've been used for years, across the industry. I mean, the DoD is a really good example of an organization that's been using these to provide application isolation. And because containers use a shared kernel and a shared container host, they reduce the amount of resources that are required for a container itself, and they're a lot more lightweight. And so therefore, containers are providing really an unmatched agility. And it's not really feasible with virtual machines because it only really takes a few seconds to start up a new container. And furthermore, containers really support a more flexible model when it comes to, the compute and memory allocation. You have the ability to do resource bursting, and so all these applications can consume more resources when required within a defined set of boundaries. And so this all kind of ties back to DevOps, right? We talked right at the start that this shift towards containers is more than just a technology shift. It's really around DevOps adoption, and DevOps adoption has really skyrocketed in the last few years, and it really coincides with the proliferation of containers within the industry. And it's not a coincidence, right? Containers have played a really important role in enabling organizations to really implement DevOps without the obstacles that they previously had faced with virtual machines. And so largely, now your IT, your ops teams are, who are responsible for building and deploying and managing virtual machines and OSs and libraries and the application dependencies and the application itself, they don't really have to do that anymore, right? Previously, it kind of created a conflicting atmosphere between your dev and your IT ops teams and any other teams that are involved in delivering that application, because now IT ops is forced into really ownership of this application and kind of these non-standard layers of technology, right? In other words, the application and its dependencies, and they're not typically going to be familiar on the ops side with all these dependencies, and they have to rely on the instructions from the development teams. Whereas with containers, when they're used as the unit of compute, there's really a clear boundary between the layers of technology within the stack. And so now it's really clear what IT ops owns and manages and what the dev teams own and manage. And dev teams that are really familiar with the application, they get to build them as well as the dependencies and all the different unique configurations. And with containers, they can really own everything across that within a container image. And so container image is then, package is delivered to the IT ops teams. And it's really just as a standard package, right? So, regardless of the technologies that are used to build the application, they now just have this standardized image. And so from there, the ops teams own the entire infrastructure, right? They own the container host, they own the virtualization, all of the above, right? And for running the standard container images, they can now deploy and monitor and manage these containers across multiple infrastructure. And they can do it using those standard procedures without the need for adapting those procedures with every single application that might have different requirements. And so ultimately, using containers, these teams are now able to work at different speeds. They're able to upgrade and downgrade servers or the applications independently of each other, and they can really easily move applications between these different environments. And so that clear ownership boundary between dev and ops, it really allows them to work seamlessly during the application delivery cycles, and it really lays the groundwork for enabling DevOps across the organization. And so really to summarize, there have been a lot of efforts to standardize the VM format. It never really succeeded. And so the VM technology, it's highly tied to the hypervisor. When you're using VMware, the VMs on premise are tied to vSphere, whereas in a public cloud like AWS, they're tied to the AWS hypervisors. Moving application to that other infrastructure, if you're moving to bare metal or another hypervisor or to a private cloud, it typically requires you rebuilding the application technology stack. And a lot of times you have to do that from scratch. And that's all going to be based on the chosen infrastructure and having to go through and redo all the verifications on the previous infrastructure. And so the industry is really moving towards immutable infrastructure. And a lot of that is to simplify deployment and management of the software. And so, using virtual machines, the packaging unit, it really requires you to build a new VM every time. And Netflix, actually, we worked with them over the last few years as an example, and they talked about this at Red Hat Summit in 2019, but they needed to make a change in production. They had to basically bake that change into a new VM and then ship the VM to production. And they now say they would have taken a different approach had Linux containers at the time been as mature as it is today. And so they've started that, or really they've moved very quickly into the container side. And so really it's all about portability. Containers provide portability, and a lot of it is due to a standardized image format. So if you've heard of Open Container Initiative, that's kind of the standard image format within containers, and they are only dependent on Linux. And so this gives teams better control over the infrastructure where they're deploying the applications. And so, container host provides really a common ground for running containers on any infrastructure, whether it's your laptop, bare metal, if it's on a virtual machine, et cetera. But, portability doesn't necessarily mean compatibility. Portability is typically believed to mean that you can take a container image and you can run it on any container host built on any Linux distro, and that's not really accurate. Container images, they're a collection of files, right? They include an operating system, they include libraries, binaries, all of the above. And so when the container images run, the binaries inside the image run just like they would on a normal Linux OS. And there has to be compatibility between the image and the container host. An example would be you can't run a 64-bit binary on a 32-bit host. And so, those kind of inconsistencies can range from, a sporadic failure, which is kind of hard to debug, to a complete failure where the container just won't run at all. And even worse, the incompatibilities can lead to, degradation of performance, can lead to security issues. And so the portability of containers is not absolute, right? If you're using different Linux distributions, if widely differing versions of the same distribution, right? You're running RHEL 5 and RHEL 8. Those kind of things can also lead to issues. So really, to guarantee portability and compatibility, it's really best practice to run a consistent version and distribution of Linux with all containers and on all the container hosts across all of these environments. And then you have your OCI standard containers combined with your standard container host, something like RHEL, and that provides really that portability, the compatibility for the application delivery. And then immutability, I mentioned this before. That's also a really key benefit, right? You now have these images that aren't really tied to a specific machine image format, like you are with VMs that are tied to AWS, AMI on AWS, or tied to VMware or something like that. And so that's really what, going back to that Netflix example, now they're adopting these containers to really enable the same kind of CD workflows, right? And now it's a lot more portable, it's a lot more efficient.
John, we have a related question.
Sure, go ahead.
From the audience. Why not use infrastructure as code to automate VM deployment? So
that's a great point. It's a great question. We're using internally, we're using things like Ansible really to establish infrastructure as code as a standard, and using Ansible to manage not just virtual machines but the hypervisors as well. As I said before, right, containers are not the end all be all, right? There are still going to be workloads that virtualizations and VMs are still going to be essential. And actually, as part of OpenShift, we've now introduced, as part of OpenShift 4.5, OpenShift virtualization, where you can actually run and manage virtual machines inside of OpenShift, and it basically be the same as if you're running them inside of like vSphere or inside of Rev, our virtualization platform. So the answer, why not use infrastructure as code to automate VM deployment? There's no reason not to, is I guess the answer. This really just kind of summarizes, this slide just really summarizes what we had talked about. Containers are Linux. The majority of containers that are running are Linux containers. And so a lot of the same skill sets from an infrastructure standpoint apply to managing containers and container hosts. The same kind of security aspects, right? We talked about SE Linux and namespaces and C groups. All of the same things that somebody that is a Linux administrator, things they're doing day in, day out at the OS level, they're now able to do at a container level as well. And so to really summarize, containers are really kind of changing the way that we think about application architecture and changing the speed at which teams can really deliver on these business requirements. Containers kind of promise application portability across all kinds of environments. And they really allow developers to focus on building their applications instead of having to worry about, is this application going to run on this underlying architecture or any kind of execution details. While containers are really removing complexity through minimalism, managing containers presents new challenges for these IT ops teams, right? Running containers on their own in an enterprise is just never going to work. Containers are deployed for a lot shorter periods of time than virtual machines, and with a lot more utilization of the underlying resources. And so related container technologies, they have to manage a whole lot more with a lot more turnover. And that introduces the need for automated and policy-driven management, which I think goes back to that initial question. A lot of teams are turning to tools like Kubernetes, which we'll talk about next, because Kubernetes has a lot of features that help them orchestrate and manage the containers across all of their environments, whether dev, test, prod. And really, Kubernetes kind of emerged as the de facto standard for container orchestration and management. And it's really become a critical platform for organizations to understand. So what is Kubernetes? And I do have to say, shameless plug, I've always just wanted a chance to use this picture in a presentation. So, how do you manage these containers, right? If you go and download Docker, you can spin up a few containers. You can even have them connected and working with each other, sort of like a service mesh. But there's a lot of management that needs to go into that, right? How do you secure it? How do you allow these containers to discover themselves, right? Containers are really popular because they allow the application to run as those isolated processes. And you sort of have to think about a container as like a tarball or like a zip file. Containers are a way to bundle code and configuration and dependencies. And so it eliminates the problem of, work on my environment, why doesn't it work on yours? But it still offers up a lot of different problems, or at least questions. And as we're building out applications as these kind of discrete functional parts, each of which can kind of be delivered in a container, that means there are more parts to manage. And so containers have, shorter lifespans. There's a lot of complexity in managing all of these containers because there are all of these additional objects and there's all this churn now. And it introduces new challenges, things like configuration or service discovery. How do I load balance? How do I scale? And how do I find and fix any kind of issues? Clusters running containers are typically running thousands of containers, right? And they're updating these clusters. It becomes basically impossible to do without some kind of automation. And really, infrastructure as code is a big part of that. Ansible is a huge part of managing and automating a lot of the day one and day two processes within the container world. And so what Kubernetes does is it really delivers a production grade container orchestration because it's able to automate a lot of the container configuration, it simplifies scaling, and it's able to manage the resource allocation. And so Kubernetes runs anywhere, whether you want your infrastructure to run on site, public cloud, some kind of hybrid, you're able to deliver these features at scale. And so in a nutshell, you have these complex applications, they have multiple components. Containers really makes that easy to update those individual components. But by placing those components in individual containers, now you have, now you can not have to worry about the ripple effects of updating a monolithic application, right? We're now talking a little bit about microservices. And so the simplicity leads to containers being this fantastic way to develop and deploy microservices. And so think of microservices, they're applications that just have a single function, and they really benefit from containers because they provide that clean separation between the components and the services. And so Kubernetes, it's an open source container orchestration platform, and it allows you to manage distributed containerized applications at a huge scale. So you tell Kubernetes where you want your application to run, and then the platform takes care of pretty much everything else. And so Kubernetes, it has a unified API. You can deploy web apps and batch jobs, databases, you name it. And the applications in Kubernetes, they're packaged in containers and they're cleanly decoupled from that environment, which we kind of talked about earlier. And Kubernetes does a lot of this automatically, right? It automates the configuration of the applications, and then it maintains and kind of tracks the resource application. And so what does container orchestration mean, right? It means that Kubernetes is figuring out where and how to run your containers. And more explicitly, it's providing three functions here. So we have schedulers and scheduling, right? So this is where it's able to intelligently compare the needs of a container with the health of the cluster. And then it suggests, where the container is going to fit. And so, think of it like kind of your thermostat, right? You set your thermostat to 70 degrees. You expect it to maintain that temperature. What the thermostat is doing constantly is checking the temperature and resolving against the setting that you set it to. And so Kubernetes is really just seeking to constantly maintain the health of the cluster. And it's freed from, I should say, because Kubernetes is worrying about that. The developers don't have to, right? They don't have to worry about the health of the cluster, and they can just focus on building the applications and innovating on features. So the second piece here is service discovery and load balancing. So with any system, service discovery is typically a challenge, and Kubernetes, certainly a challenge in Kubernetes as well, right? The more services that you have that make up your application, the more difficult it is to track and to manage the application. So what Kubernetes has is the ability to automatically manage that service discovery piece. So you might say, Kubernetes, I want you to run a service like a database or a RESTful API, and Kubernetes will essentially just take notes about the services, and then it can return a list if we ask about them later. We can say what services are available. It also checks the health of the individual services. So if it detects a crash in a service, it's going to automatically attempt to restart it. And then, beyond these kind of basic checks, it also allows you to add more subtle health checks. So, for example, maybe you have a database running and it hasn't crashed, but, what if it's just running really slowly? There's a performance issue. Kubernetes can track this and then direct traffic to a backup, right? It's essentially a load balancer failover. And then it can take down that instance really easily, spin it back up, and continue those health checks as well. So there's a lot of logic that you can build into this as well. And so, more and more we're scaling horizontally, right? We're running duplicates of a service. And so the load balancer is a really key piece that distributes and coordinates that traffic across these duplicates. And Kubernetes makes it really easy. It incorporates a custom load balancing solution like an H8 proxy, or even like cloud provided load balancers. AWS has one. I know Azure does. Red Hat OpenStack certainly does. The third component here is resource management, right? So every computer has a limit in memory, and an application that transcodes video might be more CPU bound. An application that parses text is going to be more memory bound. And so this means that CPU or that video application is going to run out of CPU first, whereas the text application is going to run out of memory first. And so completely running out of either one of those is going to lead to complete system instability and probably a system crash. And so proper resource management is really the result of intelligent scheduling. Going back to that first point, what Kubernetes does is it schedules the applications to map to the available resources. So things like CPU or memory. And it's constantly kind of staying cautious about overutilization that might lead to system instability. And so what are the benefits of Kubernetes? Well, scalability is one. You're automatically able to scale your cluster based on your needs, and that's going to save you resources and money. And remember, scaling works both ways, right? If you're a e-commerce, or retail, right? Probably Black Friday is going to be one of your busiest times. So obviously your apps need to scale. But when it gets to 2 weeks after Black Friday, there's no more sales. You need to scale back down. And so, when you have a rough idea of what the load's going to look like at these peak times, you can manually scale up and down. But with Kubernetes, there's a cluster autoscaler. There's these horizontal pod autoscaler features, and those adjustments will happen automatically. So you don't have to go in and manually scale these things. Portability, we talked about this a bit, but Kubernetes is capable of running anywhere, right? It runs on site, it runs in a public cloud, it also runs on hybrid cloud as well. And so the commands that you're using to manage Kubernetes on one environment are the same that you're going to use on another. So that allows for a lot of flexibility with scripting or automating. Consistent deployments, another big benefit. These deployments are consistent across the various infrastructures, right? Containers are supposed to embody the concept of immutable infrastructure. And so, all the dependencies, the setup instructions, they're coupled with the container, right? And some of you may have heard the about the pets versus cattle argument. Essentially, monolithic applications are pets, right? They have personalities. You've worked with them for so long. Whereas, maybe you're looking at a server, right? This server, you've done all of this kind of maintenance on the server to get it to tune exactly right. You probably named it. Whereas with cattle, right, those are containers, right? They're designed like cattle. They're supposed to be mass produced. They're identical to each other. They kind of set themselves up the same way every single time. And because they're immutable, any kind of configuration changes are really prohibited. And so there's really no fear in killing off a container and starting another one up. And that consistent experience means that developers can spend less time debugging applications and more time, building in new features. And so the final benefit we'll talk about here, it's really common for operations and development teams to be in contention, at least in my experience working with all kinds of different organizations. And operations teams, they value stability and are a lot more conservative about change. Whereas development teams, they value innovation. They prize a high change velocity. And so Kubernetes kind of resolves this conflict. There's an intelligence and an automation to Kubernetes that allows operations teams to feel confident in the stability of the system. But because containers are saving developers time, they're now kind of empowered to have these rapid iteration cycles. So I wanted to give kind of a high-level overview of the basic architecture before we move into OpenShift. But so, we have these master and worker nodes, right? And they run together, or together they run the applications of the services. And so there in the middle, you have your control plane, right? And that's roughly the equivalent to the concept of a master node. And it acts as really the brain of the cluster. And so scheduling, service discovery, load balancing, resource management, all of those capabilities are provided by the control plane. And so for this kind of high level architecture, we won't get into the details of each of those functions. We talked about that a little bit, but we'll kind of present them as a part of the control plane, right? So you have your API server, that's the point of contact for your applications. You have etcd, if the control plane is the brain, etcd is where your memories are going to be stored. So, a lot of the kind of the key value store is there. It's a really critical component of Kubernetes, and it really acts as kind of the ultimate source of truth for the cluster. It stores your cluster state and the configuration of the cluster. And then you have your worker nodes, right? So that's really, it runs an application or a service, and adding new nodes is how you scale Kubernetes. And then within those worker nodes, we have kubelets, and they're basically tiny applications that live on every worker node. Essentially, they communicate with the control plane, and then it performs requested actions on the worker node. And so that's what's communicating back to the control plane. If the control plane is the brain, the kubelet's basically the arm. Finally, we have the container runtime engine. So we've talked a little bit about this, but the runtime, it complies with the standards, the OCI standards we talked about before, and that's what runs the containerized application. So it's essentially the conduit between the container and the underlying Linux kernel. So what's missing here, right? We've talked about portability, we talked about scalability, we talked about automated policy-driven management for the users, but it's not a complete solution. It doesn't include the components needed to build or run or scale containers. It doesn't include the operating system or CI/CD tooling, application services. Where's storage at? Where's security? Look at all of these different things that we haven't yet talked about, right? We've talked a little bit about scaling. There's some auto scaling that's built into Kubernetes, but what about self-healing? What about configuration management? If you take a look at this, and this is actually an old version of the CNCF landscape, this is a map of all of the cloud native components that you need essentially to choose from if you're going to run containers in production. And so if you were going to do kind of a build your own Kubernetes cluster, you're going to need to run in an enterprise production environment all of these individual components on top of this, right? And so this is compiled by the CNCF, if you're not familiar with them, the Cloud Native Computing Foundation. They're an open source governing body. They're essentially the home to Kubernetes, right? And so this covers everything from infrastructure through application developer services, observability tools, and it gets bigger and more complicated every few weeks. I think I said, I took this screenshot of the page maybe 6 months ago, and it is enormous now. And this doesn't even include things like serverless frameworks. I highly encourage, if you're interested, the link at the bottom go check that out. It's grown massively. But essentially the takeaway is installing Kubernetes, playing around with it. It doesn't take long and it's not very difficult. But establishing Kubernetes as the platform for your enterprise to run business critical applications, it takes a lot more, right? You could probably get a Kubernetes cluster deployed in about 15 minutes, quite honestly. It'd be really, really easy to do. But take a component like identity management, which is something we haven't talked about once. Kubernetes provides access to potentially critical internal systems to employees on other teams within your organization, potentially to your customers, to your partners. And so you have to adhere to security rules that you've established within your organization. And Kubernetes doesn't really have an integration plugin built right away, right? So you basically need to find somebody that has knowledge of DEX, which is an open source identity system. They also need to have knowledge of Kubernetes and also the integration systems to LDAP or whatever identity management protocol you're using. And then you got to hook that up into Prometheus, which is an open source monitoring and alerting tool. All of these knowledge of basically 50 different things, right? Just to get one component. And so that's where something like OpenShift comes into play. And so OpenShift essentially is an enterprise version of Kubernetes, right? No matter the architecture you're choosing for your apps, no matter the programming language that your developers are programming in, no matter the services that you want to use as the building blocks, OpenShift basically is providing a simple and consistent development model across the entire life cycle, from build, test, deploy, all the way through to review. And so what OpenShift provides, on top of all of the features that we talked about with Kubernetes, and I'll just highlight a couple of these things here. Self-service infrastructure, allowing developers to provision what they need on demand and not have to open up a ticket with a team who may not get to it for the next day or week or several weeks. We've talked about consistent environments a lot, but OpenShift makes sure the environment provision for the developers from that self-service checkout is consistent from the OS, the libraries, to the runtime version. Maybe they're using Java runtime, and even the application runtime, right? So maybe Tomcat or something like that. And all of that is in order to remove the risks that originated from those inconsistent environments. And then we've automated the build and deployment process as well, right? We give a choice to developers to build their containerized apps themselves, or to have the platform build container images from the application source code or even from the binaries themselves. So the platform automates the deployment of those apps across the infrastructure based on those characteristics that the team has defined for the apps. And that those characteristics might be how much resources should this application get, where on the infrastructure should they get deployed to be compliant. And then finally, continuous delivery pipelines, right? CI/CD, we've talked about, I mentioned this a few times throughout. OpenShift provides out-of-the-box support for CI/CD pipelines. In fact, we ship something called OpenShift Pipelines as part of OpenShift, but you can easily hook in things like Jenkins or Tekton or whatever CI/CD platform you're most comfortable with or maybe already have implemented. And so this is all to automate every step of the application delivery process and really to make sure it's executed every single time a change is made to the code or to the configuration of that app. A couple other things I'll just mention. Configuration management, obviously a big part as well. Configuring and managing sensitive data within the application, those kind of things are built into the platform. And then centralized logging and metrics, right? Getting rapid feedback on your application health is extremely important. And so there's integrated monitoring and log management that really provides immediate metrics back to your developers, really in order for them to just study how the application is behaving, across the changes that you make. And then you're able to really easily fix those issues as early into the application lifecycle as possible. And so if you're unfamiliar, our development model is largely, we're an open source company, obviously. We work with open source projects to build an enterprise version of those projects. So, Red Hat Enterprise Linux, the upstream version, the open source, well, it is open source, but the upstream version is Fedora, right? We work with the Fedora community. A large subset of the Fedora community is actually Red Hatters. who are contributing upstream, understanding what direction the community is going, and then we take that and harden it and make it enterprise ready. Well, the same concept is here with OpenShift, right? We're making this enterprise ready. And so these are all the components that you're seeing across, and Kubernetes is just this orchestration component. I'm not sure if you can see my cursor, but under the container infrastructure services piece, Kubernetes is the orchestration and the storage component. And then pretty much everything else needs to be added if you're making your kind of build your own Kubernetes or is a part of OpenShift. And so, we've worked with, the Kubernetes community really since day one. Other than Google, who's the main project sponsor, Red Hat is the largest enterprise developer of Kubernetes. So, we've been a big part of the Kubernetes development for quite some time. And with OpenShift 4, we've introduced a few new features as well. A lot of this is around automation, especially around the installation piece, right? Last year, we introduced something called Red Hat Enterprise Linux Coreos, which is essentially a container-ready or a Kubernetes kind of tuned version of RHEL that is meant to be the platform for which OpenShift sits on top of. It'll be able to run anywhere, but essentially this is a foundation of a Kubernetes platform. And so we add a lot of enhancements to deliver an application platform with all the components that you need, all fully integrated. And in a lot of ways, OpenShift 4 is really just a smarter Kubernetes platform. We've streamlined a lot of the installation and the upgrade experience. And so, a lot of this is based on RHEL CoreOS. So, OpenShift can actually update the underlying OS. You no longer have to manage the OS separately from the platform sitting on top of it. All of this is kind of coupled together instead of being completely decoupled like it was in, for instance, OpenShift 3. And now you can scale at the node level, which is really useful when you deploy OpenShift on the cloud infrastructure, because now your entire cluster can scale up and down based on your needs. So you can scale from 10 containers to 10,000 with just the click of a button. And so this is allowing a lot of our customers to see value for how they're able to deliver applications more quickly, right? We see containers, Kubernetes, and DevOps really as the key ingredients for any kind of modern application platform. And all this should be based on allowing you to transform your traditional apps, build cloud native applications, and also experiment with things like analytics or machine learning or AI or serverless applications. And so the platform needs to provide a consistent way for your developers and operations teams to collaborate across all deployment footprints, whether it's edge or air-gapped, completely disconnected environments, to the infrastructure that you just have in your own data center. So a couple other things I'll mention really quickly. I'll briefly mention this. One of the big enhancements with OpenShift 4 was over-the-air updates. Customers in OpenShift 3 were struggling to install and then to really maintain and upgrade, stay up to date with OpenShift. A lot of this has now been automated. We want to make sure that updating OpenShift is as easy as updating your mobile phone. From the security piece, right? I talked a little bit about the infrastructure side, the same kind of skill set that's required for managing OpenShift or managing RHEL, a Linux platform, is the same kind of skill set that you'll need to manage the infrastructure. And then, a lot of the application security piece is built in, baked into the platform. And this ultimately should just provide a consistent container application platform across all environments. No matter what infrastructure you choose, OpenShift is able to provide the necessary tooling and process automation to enable your teams to operate Kubernetes efficiently and economically, which is always important. Another big piece of OpenShift 4 is something we call operators. And operators are a way of automating a lot of the processes across the installation to your day one, day two, and ongoing management of the platform. We're running a lot of distributed systems. They require a lot of concepts above the built-in objects that you see here, things like stateful sets and deployments. And so we need things like data rebalancing and seamless upgrades of these complex applications. And so The full stack automated install was a big piece of that, right? With OpenShift 3 and 4, you'd have to install the OS on top of the infrastructure and then OpenShift on top of that. You had to make sure that you were updating them together, but they couldn't be upgraded at the same time. OpenShift 4, everything is linked together, right? The platform and the OS are essentially seen as one unit, and so when you upgrade OpenShift, it actually upgrades the underlying OS as well. And then for here, this kind of goes back to the operators that I was talking about before, but being able to automate everything from the installation and deployment to the hardening and the day-to-day operations piece. We want to make sure that you're able to automate as many operations as possible. And some people are using operators wrapped inside of Ansible playbooks to essentially centralize their automation across one platform. Built into OpenShift is this thing we call Operator Hub. Basically, it is a repository for these automation tools, these operators. They are contributed by all of our partners, right? So storage partners, Microsoft, Amazon, Google, they all are a part of this Operator Hub. And so it's a single place for you to develop and publish your operators and to consume those operators as well. Admins have full control of this as well. So being able to say, have that role-based access control built in to fully control the access to not just the operators, but to specific pods, to specific deployments, to specific nodes. Having all of this control baked in on the administration side, but still allowing self-service for developers where they can check out operators. They can check out container images and deploy them. They don't need to file a ticket with their infrastructure team to get a test environment deployed for them so that they can check on and test the latest version of their application. And really, this is key, right? We want to make sure that things are streamlined on all sides of the house, whether you're infrastructure operations, whether you're development, whether you're high-level exec who doesn't really understand the technical piece. We want to make this as streamlined as possible. So with that, we're going to talk a little bit about training. I'm going to pass the baton over to Geraldine, who will take over the next few slides.
All right, thanks, John. Hi again, everyone. Because you're all listening in on this webinar, I'm going to go ahead and assume that you care about learning and building up your skills. So let's keep the conversation going about Red Hat training and certification. We understand that people learn in a number of different ways, and we have a handful of options for everyone. I do want to note that Red Hat training is identical in content regardless of the modality. The difference in options is based on how the content is delivered. That being said, I'll talk through the different ways to train. We've got classroom training, which will be a class that's open to the public. It's certified instructor-led and takes place in a classroom environment, often in training centers. Now, let's say you have 6 or more students looking to take the same class. We offer private on-site training that is instructor-led and delivered at your office or selected venue. The benefit with private training is that discussions, examples, and questions are relevant to your specific organization. So as you can assume, things have definitely changed due to the pandemic. So if you're looking for in-person delivery, it'll need approvals and we'll have to work together on the different delivery requirements, but we should still be able to put that together for you. Also, as a result of the pandemic, for both private and on-site public classroom training, we have seen a shift to a lot of virtual training. And these are still live instructor-led classes, but they're held online in an interactive virtual environment with the same labs that we would use in an in-person class. Our online learning features the same course content found. With the purchase of one-off classes, you'll get 90 days of unlimited access to self-paced course content, 80 hours just like this. And also part of our online learning portfolio is the Red Hat Learning subscription, which provides 1-year access to unlimited self-paced Red Hat training. And I'll dive more into that in a bit. But John, if you want to jump back to the learning path.
Sure. So, sorry, I got a little ahead of myself. I wanted to make sure that we highlight, we have a lot of training around OpenShift, depending on your current experience level with Kubernetes or with containers, and what your responsibility is going to be if you're on the IT ops side, if you're a developer. or if you're more on the security side. Most of the time, we recommend folks start with the introduction to containers, Kubernetes, and OpenShift. If container technology is new to you, really the course highlights learning to build and manage containers, right? So there's a huge focus on creating customized containers, working with containerized images, and then finally deploying them to OpenShift. Really, the course is much more around the containers and Kubernetes piece and introduces OpenShift towards the end. But really some of the takeaways, it's really geared towards developers who are interested in containerizing their existing monolithic applications. It's for administrators who are new to container technology, and then your SREs who are kind of going to be wearing multiple hats. We do recommend that anyone attending this course have some Linux experience, because a good deal of the course will take place within the command line. Now, for those of you who are developers who don't really care about the underlying architecture, you don't care about the actual containers themselves or Kubernetes, we do have essentially what is a low prerequisite on-ramp for developers who are interested in getting started with OpenShift, who just really are interested in deploying their applications and scaling them and troubleshooting them, right? So this course is really geared towards developers. Doesn't really matter what you're developing with, and really the focus again is on deploying and updating applications, giving you exposure deploying an app, scaling and troubleshooting your applications in an OpenShift cluster. You'll get experience using the web console, and you'll run into some different scenarios, right? What happens if my application health is not good, right? Really giving you experience scaling and testing and identifying and resolving common problems within the container platform. Real quick, I'll jump back to this slide because I do know there was a question in the chat around monolithic applications. Are they a bad use case for containerization? Essentially we have two schools of thought here, right? There is what we cover in our OpenShift Development 1 course, containerizing applications. That's really about taking your existing monolithic applications and containerizing them. All of our microservice architecture courses really dive into re-architecting applications to be used as microservices. And so the question within the chat was, are monolithic applications a bad use case for containers? Should apps be re-architected to use microservices before looking at containerization? And the answer is not necessarily, right? They're not necessarily a bad use case. Long term, I think it's smart to move towards microservices. That's going to be obviously easier to maintain in the short and long term. But a lot of what we do with customers when building out proof of concepts is identify specific applications and move those monolithic applications to containers to really kind of demonstrate the proof of concept of the platform, and then work with customers on re-architecting towards microservices. So I wanted to make sure I answered that question when we had the curriculum up. But Geraldine, I will move back to this slide, kick it back over to you.
Thanks. All right, so I wanted to highlight the Red Hat Learning subscription because I'm excited. We're working with our partner Fierce Software, and we're offering the standard learning subscription exclusively to Booz Allen Hamilton employees at a significant discount. The list price for this is $7,000, and you'll be able to purchase it for only $2,500 using your Booz Allen Hamilton email in Fierce's portal. So the Red Hat Learning subscription provides 1 year of 24/7 self-paced access to all 50+ Red Hat training courses. You'll get early access to classes and additional expert content, 400 hours of hands-on practice labs, and 10 course ebook downloads with the learning subscription. And so, John, if you move to the next slide, it will give you a quick showing of the breadth of our 50+ courses and the different portfolios that they fall under. Whether it's platform cloud, DevOps automation, or application development, we have training and certification paths that fit your business goals. Next slide, please, John. And I'm super pumped for these last two slides because you guys asked for it and we delivered. We didn't offer them before, but starting this month, we rolled out remote certification exams. So you can now officially get Red Hat certified from the comfort of your own home. And much like our classes, we offer classroom and on-site exams with in-person proctors. And you can also take individual exams at either an authorized testing center or now remotely in your home, office, or wherever. And these will be observed by a remote proctor. And as I'm riding this wave of learning subscription excitement, I want to also note that the standard learning subscription includes 5 unique exam vouchers and 2 unique retakes, which you can definitely use for remote exams. So that's all the fun stuff I had for training for everyone today. I'll be sticking around a bit for any training questions, but thanks again for taking the time out of your week to join us. And I'll kick it back to John and Jamie.
Yeah, Jamie, sorry, I kind of jumped the gun here. Back over to you.
No worries at all. Could you go to the next slide, please? So thank you very much, John and Geraldine. To bring it back home for our Booz Allen platform, in our slide deck here, if you click on the Red Hat tile, it will take you to our degree page, which will give you a variety of training opportunities available for the Red Hat, the different Red Hat systems, most of which Geraldine or John discussed. The next tile over will take you to the Red Hat OpenShift degree page, where you will find training specific to OpenShift. And finally, on our last tile, that will take you to the Red Hat Learning subscription that Geraldine spoke of earlier, where you can sign up to take advantage of that deeply discounted learning opportunity. Next slide, please. So all that said, some of you may be unsure of where to get started on your Red Hat journey. And you can click that link right down there and assess your skills on a variety of Red Hat related subjects for free. And after you finish with your assessment, then you can go back over to the degree page and pick up on your learning journey. Next slide, please. So finally, I'd like to ask you all to please take a minute to complete our short survey and let us know how we're doing and what future topics you'd like to learn about. Would you like a repeat of this webinar? Would you like a webinar on Red Hat OpenStack? Let us know and we will be happy to spin it up. Next slide, please. And now I'm going to open it up for Q&A. John, I know there were several questions that were posted to you in the chat channel, so I will turn it over to you to address those questions, and then we'll be happy to take some either verbally or again in the chat after that.
Yeah, so the first question I see here is, how easy or difficult is it to implement Kubernetes in air-gapped networks? So I know at least in OpenShift, this is actually a relatively new feature that was introduced in OpenShift 4.4. We just launched 4.5, so this is probably 2-3 months ago that we launched this. And so I think for a long time, at least Kubernetes, it was, I won't say near impossible, but extremely difficult. And even with the automated process that we've introduced into OpenShift, there's still a lot of work that needs to be done ahead of the installation. But once that kind of pre-work is done, most of the installation piece is automated at this point. And so, there is some manual control you have to do throughout the automation process, but we've tried to make this as much of a full stack automated installation as possible. So, really once you have the infrastructure, ready to go, you have the essentially the network ready to go, you're able to essentially run a few commands to get that full stack automated install going. And at that point, you're able to say this is going to be an air-gapped install as well within a disconnected environment. So much easier than it was even 4 or 5 months ago. The next question, does OpenShift 4 handle patching nodes, OS and other patches? So yes, right? So with OpenShift 4, because it's coupled, well, essentially with OpenShift, you have a couple different ways of installing. So there's the full stack automated method, which essentially attaches OpenShift to the underlying OS. In this case, it would be RHEL Core OS. Or you can still do it the traditional way. You might hear this referred to as IPI versus UPI. It used to be full stack versus manual, something like that. But essentially with an automated install, patching OpenShift and patching the nodes also patches the underlying OS. Now you may need to still go in, and if there's a kernel vulnerability or something like that at the OS level, There may be some manual updates you would need to do at the OS level, but for the most part, it's coupled. Whereas with that user provision install, it is still needed to manage the platform and the OS separately. Kubernetes allows for bidirectional traffic into a secure enclave. Working with secure enclaves, what are some best practices to reduce traffic and secure traffic? Can we only have containers that only push information but not take updates? Can we control access to a secure enclave, only have traffic coming from a secure enclave? So ingress and egress is really what this comes down to, and you have complete control around the internal and external traffic. What a specific pod accepts versus what it sends out. All of these things can be controlled at the pod, the individual container or the pod level. So you most certainly have control of access to these secure enclaves and only have traffic coming from that specific location, most definitely. And I think the last question we have, in an AWS cloud, do we need to use auto scaling to scale the number of worker nodes, or Kubernetes manages the worker node scaling? So I know that OpenShift running on AWS has a lot of the same features that OpenShift running on bare metal would, and so a lot of the scaling is automatic, and you can build in logic and make it as manual as you would like. But the auto scaling is a part of OpenShift or a part of Kubernetes, regardless of where it's being deployed. So if it's on AWS, if it's on top of OpenShift, or OpenStack, I'm sorry, or if it's just running on bare metal, you have those scaling worker node scaling capabilities built into the platform. It looks like that might be the last questions. If there's anyone else that would like to ask, otherwise I know Scott added an email address in the chat box, so if you have any follow-up questions, he can always get in touch with me and I can answer those too. All right, well, with that, Jamie or Scott, I'll kick it back over to you.
Perfect. Thank you so much to you, John, and to you, Geraldine, for being with us and presenting for us today. Thank you, Scott, as always, for your support backstage. Again, thank you, everyone, for joining us today. If you have any follow-on questions, feel free to reach out to cormac_scott@bah.com. And again, please take a minute to fill out our survey and let us know if you would like a repeat of this webinar or any other topics you might be interested in. Thank you all. Have a good day.